barns that you live in. So yes, they're going to dig a big basement, and that's going to be their shop, and then they're going to.
Check 1, 2. Check 1, 2. So if I do that, I'll get check, check, check. And that's going. And we will transition. Let's do this.
All right.
There we go. All right, good afternoon, everybody. Hey, Gail and I decided to do a little switcheroo today. She is running the camera equipment, and I am presenting. So, good afternoon. I'm David Dubczakk, your presenter for today. You normally see me running the camera, but let's see. I'm going to do my best Gail impression here real quick. Welcome to the Iowa Files on this lovely Sunday afternoon. Iowa Files is brought to you by the Friends of the West Des Moines Library, the Diana and Scott Hatfield, and the West Des Moines Historical Society members and donors. How was that? Pretty good? All right, wonderful. And Gail gave me the thumbs up too back there. And if anything goes wrong with the broadcast, she's going to be frantically waving at me, and I'll give a pause and I'll go back and fix things, and then I'll come back up and continue with the presentation. So a little bit of double duty today. All right, I am David Dubczakk. I am, for my day job, I'm a teacher. I am soon to be a newly licensed school administrator, but I am also a longtime space and space history enthusiast. And when we were looking at different things that we could present for this year, I said, you know, Iowa has had a number of really, really important contributions to the United States space flight program, both in the science of space and in humans traveling in space. A number of really important contributions. We were not just providing corn syrup for astronaut food. And so happy to be able to present on that today. And normally when I talk to people for an hour about space, it's to a group of people that haven't asked me to. And so I'm really delighted that you've all come today. So let's get started. So first of all, who am I? I'm the kind of guy who goes to space camp as an adult. All right? But it wasn't just me. This is actually a group of teachers. We got to go have the space camp experience and also learn how to apply that to being an educator. So that is the kind of person that I am. And about 10 years or so ago, when I was getting my first master's degree, I had a graduate internship at the Air and Space Museum in Washington, D.C. And when I was there, I worked in the astronomy education department, did some stuff with D.C. public schools and their solar observatory, where we got to look at live views of the sun during the day, pulling people off the sidewalk. That was pretty cool. But you're here to figure out what was Iowa's influence on the space program. And in many different ways, our space program was made possible by some significant Iowans and Iowa-based corporations. But in order to get to where we are in this, we have to go back to the beginning. The very beginning. The very, very beginning, which is going to be a place we don't really like to talk about. Should I go there? Nazi Germany. Okay, let's go. World War II Germany was really where the foundations of the United States space program began. In the 1920s, the Germans had the best technical universities. And so by the 1930s, the Germans had the best scientists. And really by the time World War II broke out, they had science and technology that was way beyond what we had in the United States. Many of you might know the airplane that we had, the P-51 Mustang, was really the height of our aviation technology in World War II. And there are stories of late in the war, P-51 Mustang pilots getting absolutely blown away by German fighter jets. And the way they described coming against these German fighter jets, it's like they were going up against UFOs. They had no idea how a plane could be so fast and so maneuverable. And they had fighter jets in combat when we had jet engines just in a laboratory setting. And so that's how far ahead they were. When it comes to space and rocket technology, the rocket that you see here is called the V-2 ballistic missile. And what was important about the V-2 is that it was the first practical liquid-fueled rocket. So a solid-fueled rocket is like a firework, and fireworks had been around for 1,500 years at this point. But solid rockets have a number of problems with them. A solid rocket, when you light it, it burns at 100% until it's empty. If we're going to travel into space, we need a little bit more control than that. We need to be able to throttle it up and throttle it down. We need to be able to, it's called thrust vectoring, which is where you're pointing the directions that the gases go. We need to be able to thrust vector them to steer the rocket. We need to be able to start, stop, and restart the rocket, all things we can't do with fireworks. And so liquid-fueled rockets are really what we need in order to go through space. And the German V2 was the world's first practical liquid-fueled rocket. It was meant to be battlefield deployable, which meant that they could put it on the back of a truck, drive it to wherever they wanted to, and launch it from there. I don't know from my research if they ever actually did that or if they just launched it pretty much from the missile base at Peenemünde, Germany, which is where it was developed. But world's first practical liquid-fueled rocket. Now, the United States at the time was working on liquid-fueled rockets. This is Dr. Robert Goddard, who was the pioneer for liquid-fueled rockets on the American side. But I want to be clear with this. During World War II, Dr. Goddard's rockets were in research and development labs at the same time the Germans had V2s on assembly lines. Okay? They were significantly further ahead than the United States was in World War II. Now, Dr. Goddard's counterpart in Germany, his name was Dr. Wernher von Braun. And I'm going to talk a little bit more about him in just a minute. He becomes kind of a controversial figure in history. And there's a lot of debate whether he is an American hero or a war criminal. And we're going to get to that in a second. But he does eventually come over to the United States and become a significant figure in our own spaceflight programs. So, at the end of World War II, both the United States and Russia realize the Germans' technology is way far beyond what we have. And there were kind of two operations at the end of the war in a mad race to get Germans' science and their scientists. So we have Operation Paperclip, which was to get the German scientists, and then the very fun name Operation Lusty, which stood for Luftwaffe Secrets and Technology. Luftwaffe was the German Air Force. Operation Lusty was to get the science. And so we wanted their science, we wanted their scientists, and we wanted to get them before the Russians. And so Operation Paperclip was a big story. It condenses down to something like this. All these scientists had to go through customs and immigration. When they went through immigration, if there was a paperclip on their immigration file, don't look too hard for evidence of war crimes. We don't want people like Dr. Mengele coming over, but we do want people like Dr. von Braun. And that was the theory at the time. And so a lot of them wound up at Fort Bliss in Texas. These are the scientists that were brought over under Operation Paperclip. Fort Bliss was their first stop, but they did wind up going all over the country. Von Braun and most of his team wound up going to White Sands, New Mexico. Some of his team wound up in Russia, working with von Braun's counterpart in Russia, which was his name was Sergei Korolev, was their chief rocket designer in Russia. But anyway, most of the von Braun team, through Operation Paperclip, winds up in White Sands, New Mexico. Now, let's talk about von Braun himself. This is a case of things are not as clear-cut as they seem. The story was when he was a kid, he looked at the moon through a telescope and decided that he personally wanted to set foot on the moon. And he set forth his entire life to the study of rocket science, which he knew would take him there. Now, in 1930s Germany, there was only one employer of rocket scientists, and that was the Army. And he was a member of the Nazi Party. There is no evidence that he subscribed to the horrible ideology of the Nazi Party. There is plenty of evidence that he and his team sabotaged the development of the V2 as long as they could without getting in trouble. There were a number of, these are people who wanted to build rockets. And there were a number of problems that they had to solve, which, given their capabilities and the type of problem, took probably too long for them to solve than it needed to. And so there's some evidence that they sabotaged the development of the V-2 to keep it from being used as a weapon of war. But nonetheless, it was a weapon of war. It was a weapon of mass destruction. It caused a lot of damage in London, and it was built by Jewish slave labor on assembly lines. And with as hands-on as Dr. von Braun was, there's no way he didn't know that. Now, through Operation Paperclip, he was brought to the United States and becomes the chief rocket designer for the U.S. human spaceflight program. In fact, the Saturn V rocket, which carried Americans to the moon, he was the lead designer on the Saturn V rocket, along with many of the same people he had in Germany working on the V-2. And so, the V-2 really is an important rocket in not just German history, but also American history, which I'm going to touch more on. So, can you take a long view of somebody's life, look at both their sins and what they've done to make up for their sins, and then judge whether they've made up for past sins? Well, you get to set that criteria. So you get to set the criteria for yourself to determine whether or not the sins of his later life made up for what he did in his later life made up for the sins of his earlier life. So anyway, we have to keep talking about the V-2, because that does connect to Iowa, believe it or not. So, not only did we bring over the German scientists and take them to White Sands, New Mexico, we had a couple of dozen captured V-2s. And after the war, it was important we had the scientists, and it was important that we had their rockets, but we didn't really know what we wanted to do with them. So we set them forth in White Sands and said, have fun. And so what did they do? They're like, well, we are rocket scientists. We're going to do science with rockets. And they set forth to continue to develop the V-2, continue to make it better. You know, the V-2, if you know anything about rocket science at all, it had an inertial guidance system where it had gyroscopes guiding it. They worked to develop an electronic guidance system. They put sensors in the nose cone instead of bombs and did atmospheric experiments. One of the atmospheric experiments they did, they took the first photo of the Earth from space. So this is the first photo of the Earth taken from space, launched on a V-2 missile from White Sands, New Mexico. Now, pretty soon thereafter, the Korean War breaks out. And the Army comes to von Braun and his team and says, hey, you know that battlefield deployable ballistic missile that you built for the Germans? We want one. And so what did they give him? They gave him a V-2. Okay? Now, it was actually called the Redstone. They moved von Braun and his team out to the Redstone Missile Arsenal in Alabama, and they built the Redstone missile. But the Redstone missile, this was a V-2. Okay? If you took the skin off a Redstone, it was a V-2. When it comes to like the fuel pumps and the rocket nozzle and things like that, the basic systems are the same. There might be some improved metallurgy, some weight savings. Like I said, it had an electronic guidance system instead of an inertial guidance system, but still, you take the skin off a Redstone, and it's a V-2. All right, and this is what the Army has in the Korean War. Now, let's fast forward to 1957. We know Russia wants to launch something. We know Russia's planning something. And so we should be planning something too. And the problem at that time, though, was the Redstone belonged to the Army. And the Pentagon had decided that space belongs to the Navy. And the Navy did not want the Army's rocket. And so the Navy, they built, with their own team, a rocket called the Vanguard. And the Vanguard had one really critical weakness in that it didn't work. Okay? They tried to launch it a number of times, and you would get things that look like this, which is just the Vanguard blowing up on the launch pad. One time, so in December of 1957, this was just a few months after Sputnik was launched, Vanguard blew up on the launch pad, and the little satellite in the nose cone was ejected into the nearby woods, and it's designed to think, hey, when I leave the nose cone, I'm in space. So it lands in the woods and then starts doing its thing, broadcasting a radio signal from the woods. And the media had a field day with that. They called it Kaputnik and Stay Putnik. All right? So, in the meantime, you got von Braun jumping up and down, screaming, "My rocket works!" And eventually, the Pentagon relents and decides, okay, we're going to let von Braun and his team use their Redstone rocket to launch a satellite into space. But we need a satellite. And we want a satellite that can do something besides just beep a radio signal. We want a satellite that can do science. And so they put out a call for proposals to science departments from across the country. And one of the winning proposals, actually, I'll get there in a second. What do we launch the satellite on? A V2, actually a Redstone, okay? Now, we launched it on the rocket they called the Jupiter C, which is really a Redstone with a second stage on it. And remember, the Redstone is really a V2. All right. Now, Explorer 1 is the satellite. Explorer 1 was designed and built by Dr. James Van Allen at the University of Iowa. And so, Dr. Van Allen was an astrophysicist. He theorized that the Earth's magnetic field kept at bay solar radiation from the sun and cosmic radiation from elsewhere in the universe. And that a couple hundred miles above the surface of the Earth, there would be a dense boundary of cosmic radiation held back by the Earth's magnetic field. And they thought, or what they wanted to do with Explorer 1 was design an instrument package that could see whether or not it was there. And in fact, it was there. You can kind of see how it's depicted in this. But to this day, they refer to that area as the Van Allen belts. And if you're going to design a spacecraft to go into low Earth orbit, like the Space Shuttle or the International Space Station or the SpaceX Dragon, which takes crew up to the space station now, or the Russian Soyuz, you don't need the level of radiation shielding that you would need to go out past the Van Allen belts, like you would if you were going to the moon or Mars or something like that. And so the Van Allen belts is an area of dense radiation kept at bay by the Earth's magnetic field. The instrument package was designed by Dr. James Van Allen of the University of Iowa, who is in the center of that picture there. But Dr. Van Allen, as I was researching this, I found an article from Time magazine in May of 1959. And so I'm just going to read to you a couple of paragraphs from this article about Dr. Van Allen. In 1950 came an event that began small, but was to affect the future of Van Allen and all his countrymen. In March, British physicist Sidney Chapman dropped in on Van Allen and remarked that he would like to meet other scientists living in the Washington area, which is where he was living at the time. Van Allen got on the phone, soon gathered 8 to 10 top scientists into the living room of his small brick house. It was what you might call a pedigreed bull session, he says. The talk turned into geophysics and the 2 international polar years that had enlisted the world's leading nations to study the Arctic and Antarctic regions in 1882 and 1932. Someone suggested, with the development of new tools such as rockets, radar, and computers, the time was ripe for a worldwide geophysical year. The other men were enthusiastic, and their enthusiasm spread around the world from Washington. The International Geophysical Year, 1957 to 58, stimulated the US government to promise Earth satellites as geophysical tools. The Soviet government countered by rushing its Sputniks into orbit. The race into space may be said to have started in Van Allen's living room that evening in 1950. Within a few months of starting the space race in his living room, Dr. Van Allen was offered his professorship job at the University of Iowa, and the rest, as we say, is history. And so we have this sign at the entrance to our states. I suggest a small modification to this sign. Okay, I think that might be more appropriate. All right, but now it's time to go to the moon. How do we go to the moon? Well, we start on top of a Redstone. But in May of 1961, we launched Alan Shepard into a suborbital flight on top of a Redstone rocket. And with a cumulative total of 15 minutes of spaceflight experience, President Kennedy said, we're going to go to the moon. And so how do we do that? Now, by the way, Alan Shepard was the first US astronaut into space. The first US astronaut to orbit the Earth, he was the third astronaut in space, was John Glenn. And John Glenn learned how to fly at US Navy pre-flight base, Iowa City. And so this was in World War II. They needed to train a lot of pilots very quickly. In Iowa City, the pre-flight base was open from May of 1942 until August of 1944. They trained 2,500 pilots during World War II in Iowa City, including young John Glenn, who is on the left of that photo. All right, so how do we get to the moon? If you're here because you know a lot about space, you can give your brain a break for 5 minutes because you're going to know this part. If you're here because you want to know about space, here we go. Here's how you get to the moon. Eventually, we put together the Apollo spacecraft. The Apollo spacecraft has 3 parts. The one that actually lands on the moon is called the lunar module. That's the part that actually lands on the moon. The part that the astronauts live in on the way to and from the moon is the command module. Has just enough room for 3 people to survive for about 2 weeks. And then this part has no living space, but that's all of their life support. Their water, their fuel, their oxygen, things like that. That's all their life support. Now, in order to get there, actually I'll back up real quickly. So what would happen is we would launch this entire setup to the moon aboard the Saturn V rocket. This is one of my favorite photos of Dr. Von Braun. It's like, hey, Doc, what are you working on? Oh, just something I made over the weekend. You know, that's what that looks like. 7.5 million pounds of thrust there behind him. But you would launch, actually when they launched this, the readout was able to be measured. So they launched it on Florida, in Florida. They were able to measure the readout on earthquake sensors in California. Okay? Yeah, that's a lot of thrust. 7.5 million pounds of thrust. But it was done in stages. You would have your bottom section. This would burn for about 2.5 minutes and just get the whole thing above the Earth's atmosphere. And then the second stage would burn for about another 6 to 8 minutes, and that's what accelerated them into orbit around the Earth. Your third stage would then push them away from the Earth toward the moon. The lunar module is hidden inside this little cone shape right there. When they are on the way to the moon, the command module would do an about face, turn around, pick it up, and then they would continue on to the moon. The third stage would either fly out into space or it would crash into the moon. Kind of chase them all the way there and crash into the moon. All right, when we get to the moon, the 2 spacecraft would separate. Two of the astronauts would crawl into the lunar module. The lunar module would descend onto the surface of the moon. The reason it looks the way it does is because it is lightweight. It only weighs as much as it needs to go down to the moon and back up. And then when it's time to come back up, only the top part would actually come back. So we did 6 landings on the moon, and the descent stage, which is the bottom part, the descent stage, all 6 of them are still there on the surface of the moon. And this photo was taken from Apollo 17, which was the final moon landing. And there's about a 4-second delay in radio signals between the moon and the Earth. And so one of the mission control people was able to remotely operate the camera that was on their rover. But he had to tilt the camera upwards, but he had to give the command to tilt upwards 4 seconds before they actually did it and time it right. It took him a couple of missions to practice getting that right. By Apollo 17, he got it right, so we could get footage of the ascent stage lifting up. So, but the ascent stage would come back, and then the astronauts would come back home. This was a technique called 2-pilot orbital rendezvous. Rendezvous is a French word that means coming together. That means we're going to fly 2 spacecraft and dock them together. Here's a little bit of history for you. Buzz Aldrin, who was the second person on the moon with following Neil Armstrong down the ladder. Buzz Aldrin, before he was an astronaut, he was a Navy pilot. And when he got his engineering doctorate, he wrote his doctoral thesis on 2-pilot orbital rendezvous. Because he could see that if you're going to take 1 spacecraft to the moon that can do everything, it's going to be too heavy. There's no way we can launch that from Earth with the technology we have. The reason we do two-pilot orbital rendezvous is really weight savings and fuel savings. And he could see that's what we needed. And so he wrote his doctoral thesis on this, working out the math and the physics that they would need to learn in order to do it, so that when NASA realized they needed two-pilot orbital rendezvous, they came calling to the person who had literally written the book on how to do it. So that was how Buzz Aldrin got into the space program. And if you ever go to trivia night, it might be useful to remember that Buzz Aldrin's mom's name was Marion Moon. Uh-huh. All right. So to get to the moon, there are some things we need to learn. We need to learn how to fly two spacecraft together in close proximity without running into each other and then docking them together. We need to learn how to ground track two spacecraft so that from the ground we can keep track of where both of them are. We need to learn how to communicate between each other. We need to learn how to communicate with the ground. We need to learn how to transmit data. That becomes really important here because before this, radio communication was glorified walkie-talkies. They had never transmitted anything but voice before, and now we have people on the ground that want to keep track of every operation that's happening on the spacecraft. Every component, we want people on the ground to be able to keep track of how that's running so that the astronauts can fly it and sleep from time to time. So we want people on the ground to do that. That means we have to transmit data. We have to have sensors that can read the data, code it into something that can be sent over the radio, picked up on the ground, decoded into something that can be displayed on Mission Control's computer. They had to invent all of that. We had to learn how to survive in long-duration spaceflight, because it would take about 2 weeks to get to the moon and back. Then we had to learn how to work outside the spacecraft. And so that was the job of Project Gemini, which was a quick little two-person spacecraft where they learned how to do all those things. In Earth orbit, they practiced Buzz Aldrin's technique of docking them together, flying them together, learned how to work outside the spacecraft. And there are some really kind of horrific stories out of this era of people almost dying. Like the first time they had somebody do a spacewalk and they said, we're going to put tools in the back, and we want you to crawl out, crawl to the back, and get them. And Mission Control, monitoring his heart rate, thought he was going to have a heart attack because he was just working so hard to get there. And they realized we have to figure out a better way to do this. And Buzz Aldrin actually saved the day again because he's like, that kind of sounds like scuba training. And that's how they learned how to train astronauts. All right. But anyway, now, as I said, radio communication. For the first time, we had to transmit data, and hundreds of channels of data. And they had to convert it into a format that could be broadcast from the spacecraft and picked up at Mission Control. It actually had to be picked up anywhere in the world. It had to be able to be picked up no matter what side of the world was facing the spacecraft, and then relayed to Houston. And that was all made possible by the Collins Radio Company out of Cedar Rapids. So, the Collins Radio Company had been a military contractor going back to the World War I days, where they built radios for ships and radios for airplanes. And so being able to do kind of a global communications network was something that the Collins Radio Company had a lot of experience with. And so when NASA needed to build a space communications network, they came calling to the Collins Radio Company. And so, I should have had their logo up there about 30 seconds ago. Anyway, the Collins Radio Company out of Cedar Rapids. And so what you see here, the top two pictures, those are pictures of testing some of the radio equipment, testing their procedures and things out at laboratories at Collins. But then also the ground tracking stations. They had to put these stations, the photo at the bottom is a ground tracking station. They had to put these all over the world because the spacecraft was orbiting the Earth. And when they're on the other side of the Earth, the radio signal can't get to Houston. And so they have to bounce radio signals all over the Earth to get this data back to Houston, no matter where the spacecraft is. And all those systems were designed by the Collins Radio Company out of Cedar Rapids. But this is not the most significant impact that the Collins Radio Company had on the Apollo program. The most significant impact that the Collins Radio Company had was with this. This was the moment of seeing Neil Armstrong climb down the ladder of the lunar module onto the lunar surface. It was broadcast live and watched by billions of people all over the world. This was never intended to be broadcast live. First of all, I talked about the hundreds of channels of data that they needed to broadcast. NASA didn't think that there was room in the radio signal for a TV signal. And so that was part of it. On the other part of it, they're like, okay, you want them to land a spaceship on the moon and operate a camera? Okay. NASA was kind of focused on, let's do the important thing, let's land. So we would have heard the voice of them landing on the moon, and we would have gotten pictures a couple of days later when they returned to Earth and developed them, if the Collins Radio Company had not intervened and insisted to NASA that we can build a video signal into our radio signal, and we should. We can and we should. And it was the Collins Radio Company who made this moment possible, or made it possible for billions of people around the world to see this moment live. So, Collins Radio Company out of Cedar Rapids. Now, then the conspiracy theorist says, but who set up the camera? It was attached to the leg. All they had to do is press a button and it would pop out, already pointed at the ladder. Okay, that's how it was done. Today, the Collins Radio Company is called Collins Aerospace. And actually, interesting enough, through a series of mergers and acquisitions, they also now own the company that makes the spacesuits that are used on the International Space Station. I took this. This is a screenshot from the Collins Aerospace website. So these are all the things that they do today. And they actually have a building here in West Des Moines. It's, if you go down Grand Avenue by where the Dairy Queen and the Taco John's and the Fairway is, there's a building just about a block back from that says Collins Aerospace on it. And so, yeah, they have a building still here in West Des Moines. All right. But that's not all. We're not done yet. So Apollo 11 was the first one to land on the moon. About 1 minute before they were supposed to touch down, they got a very serious computer error. This is called a 1202 program alarm. What the 1202 program alarm meant was that the computer was being overloaded with data. It was processing too much, and it was actually dropping commands because it couldn't handle everything that was coming at it. That situation might sound familiar to you because it's the normal state of the human brain in 2025. Okay? But I'll let that one sink in a second. All right. 1202 program alarm. Now, about a month before Apollo 11, Mission Control did a simulation. And when Mission Control does simulations, they're run through the mission, and you have simulation supervisors who throw problems at them and see how the Mission Control people handle that. And in the final simulated mission, before the real Apollo 11, the simulation supervisors gave them a 1202 program alarm. And following the books strictly, procedures called, well, you really need your computer to be able to land, and if the computer is overloaded and not working, we need to abort the landing. And so in the final simulated mission before landing on the moon for real, they aborted the landing and said, well, we didn't land, but we kept the astronauts safe and got them home safe. So good job, us, right? And then the simulation supervisors came and said, no, you failed this. Because, yes, procedure said abort, but the computer was still functioning. The computer was still doing all the things that it needed to do in order for you to land. It just said 1202 alarm. And now Mission Control and the flight directors are really upset with this because they say, you know, our last training mission is supposed to be the feel-good mission. It's supposed to be the one where they set us off, be like, you guys got this, you know what you're doing, now let's go do it. That's what's supposed to happen in the final simulation, and now here, Mission Control failed their final simulation before landing on Apollo 11. Well, it's a good thing they did, because when we get to Apollo 11 for real, about 1 minute before landing, we get this 1202 program alarm. And now they've got 30 seconds, even less than that, to decide, continue landing or abort. look at all the data, make the decision. The flight controller responsible for making that decision was Ottumwa native Steve Bales. And he looked at the decision, remembered their training, said, we have this alarm, but the computer is still functioning, called the go, they continued to land. And they went and landed, for the first time, landed humans on the surface of the moon. So, now, when they did an investigation afterwards to try to figure out why they had the 1202 alarm, it was Buzz Aldrin's fault. He had accidentally flipped a switch that enabled the rendezvous radar, which they needed to dock the two spacecraft together when they were done. And so the spacecraft was trying to process information from the rendezvous radar, which it did not need to be doing at that point, and that's why it had too much information. So that was the 1202 alarm. All right. I was not done with space yet. In the 1970s, we launched the Voyager space probes. The Voyager space probes were the first two to travel outside of our solar system, outside of what they call the sun's sphere of influence. Along the way, they traveled past Saturn, Jupiter, Neptune, Uranus. They took our first good pictures of those planets that were able to be sent back to Earth. And keeping in the tradition from way back 20 years earlier with Explorer 1, many of the sensors on this were designed at the University of Iowa. And so the University of Iowa actually has a pretty big astrophysics program. And so they still have involvement with NASA and with space science today. Now let's go to the rocket, the Saturn V, that took people to the moon. Saturn V, up until just last year, was the most powerful rocket that had ever been built in human history. A lot of the aluminum for that rocket was rolled at Alcoa, the aluminum company of America, which is out of Davenport. Davenport at the time, or Alcoa, had the largest aluminum refineries, the largest aluminum rolling facilities, and they needed big sheets of aluminum to build this rocket. And so a lot of the aluminum for the Saturn V rockets was pressed at Alcoa in Davenport and then shipped to the assembly facilities. Now let's talk about some astronauts. Walter Cunningham from Apollo 7 was born in Creston. Apollo 7 was the first human flight of the Apollo program. So Apollo 1 had an accident. It burned on the launch pad, and the entire crew was killed in that. Apollos 2 through 6 were then uncrewed test flights, and then Apollo 7 was the first launch with people in it. And so Walter Cunningham, this was his only flight in space, but he was on Apollo 7. And then we have a number of other astronauts. So James Kelly of Burlington, George Nelson of Charles City, David Hilmers of Clinton, Lauren Shriver of Jefferson. There's a couple more I'll bring up in a second, but between all these astronauts, between Iowa's astronauts, we have one Apollo flight, 14 space shuttle flights, 2 Soyuz flights to the International Space Station, 1 SpaceX Dragon flight, and 1 private space flight with SpaceX and Axiom Space. A couple more astronauts here. We have Raja Chari, who graduated from Cedar Falls, but actually spent most of his life in Wisconsin, but did live for a while in Cedar Falls, so I count him in here. But then Laurel Clark was on the ill-fated STS-107 of Columbia. Columbia was the one that disintegrated upon re-entry in 2003. And so she was from Ames. Actually was born in Ames, did spend most of her life, though, in Racine, Wisconsin, graduated from the University of Wisconsin, but does have family back from the Ames area. For those of you who don't know Space Shuttle Columbia, when it was launched, a suitcase-sized piece of foam fell off the orange external fuel tank and hit the wing of Columbia and punched a hole in it. And this was something that the important people did not know about until later when Columbia disintegrated on re-entry. And if you're interested in this, I recently read the book Bringing Columbia Home, which is the story of both collecting the debris, collecting remains of the astronauts, assembling it, and then trying to piece together a picture of what happened. And this is really a terrific book, Bringing Columbia Home, if you are interested in stuff like that. Iowa's not done yet. One more significant astronaut from Iowa is Peggy Whitson. Peggy Whitson actually holds the record for the most cumulative time in space of any American astronaut. As of today, it stands at 675 cumulative days in space with, what is that there? Four different flights. Four different flights. Was one of the people who helped build the International Space Station. She's from Mount Air. But yeah, the most cumulative time in space of any American astronaut. There are some Russians who go even up to 1,000 cumulative days in space. But on the American side, she holds the record, the most days in space of any American astronaut, with sitting at almost 2 full years in space across her flights. So today she's retired from NASA. She works for a private company called Axiom Space. She was the commander of Axiom Mission 2 and is slated to be the commander of the upcoming Axiom Mission 4, which, if you don't know anything about Axiom, I don't know much about them either, but they purchase flights on the SpaceX Dragon, and they send their own people up there. Now, Iowa's not done yet. Both the University of Iowa and Iowa State have astrophysics degree programs. They still continue to build components for satellites and spacecraft. The International Space Station is a floating research laboratory, and so universities from across the country send in research to be done on the International Space Station that can only be done in a microgravity or weightless environment, and that's why they're done on the space station. And so, many of our Iowa universities, I don't know any specific experiments that have been done, but many of our Iowa universities have sent scientific research packages to the space station. And usually when that happens, they've designed the experiment, they've designed the procedures, NASA sends up the equipment, and then they train the astronauts on board how to do the experiment. And so that's how science is done on the International Space Station. One type of science that's done on the station today, I can tell you, is medicines. There are some medicines where the crystal structure of the chemistry, the crystals can only form the way they need them to form in a weightless environment. You cannot do this chemistry on Earth because gravity affects how the crystals develop together. And so you have to send it to the International Space Station for them to do the experiments there. And that's part of what's done on the International Space Station. So, that concludes my presentation on Iowa's influence on the space program. I was actually unable to find any instances of Iowa corn syrup being used in astronaut food. Thank you for laughing at that. My wife told me not to be mad if no one laughed at that joke. Anyway, now, outside of doing this, I'll take your questions in a second, but outside of doing this, like I said, I'm a teacher. I am soon to be a newly minted school administrator, just looking for a school to lead, so if you know one of those, let me know. If you know one of those in the area, I've probably applied, so let them know that you liked this presentation. I've also written a number of books for upper elementary kids and teens. I'm a playwright as well, and I've got kind of a sampling of that on the front table. But before I conclude here, now, like I said, I'm an enthusiast. I may not be able to tell you much more beyond what I've already told you, but I mean, if you have questions, I can make an attempt at answering any questions that you guys may have. So, any questions that popped up from today's presentation? All right. Well then, in which case, Gail and I are going to do a quick switcheroo. And Gail, I'm turning your microphone on here. So she and I are going to do a quick switcheroo, and she will take you into next month's program. So thank you very much, everyone. Thank you. Thank you.
give somebody a little bit of power and it goes to their head. Talking about the history of indigenous people in Iowa and some of the white settlement issues, and we hope that you join us. If you are a crafter, we are going to have our first, because the storm got us, social hour at the Jordan House on the first Wednesday in April. So that is 6:30 to 8, and it's for anybody who knits or tacks or crochets or needlepoint, any of that stuff. It's a time to come and be social, practice your craft. If you're just learning, we'll have experts there that will help you with that, so nobody pokes themselves too hard with needles. We also have a new exhibit that's going to be opening officially on Friday. So Victorian leisure activities, so please stay tuned. I hope you come visit us. Jordan House has tours on Fridays and Sundays, 11 a.m. and 1:30 p.m. Thank you so much for coming today.